Welcome to G Fun Facts Online, your go-to spot for the most amazing tidbits from the world of science and tech. Today, we're tackling a colossal topic: construction. We all live in buildings, drive on roads, and use structures built by this industry. But here's a thought. The traditional way of building has a pretty hefty environmental footprint. So what if we could build smarter, greener, and more sustainably? Well, the good news is, we can. We're about to explore some truly revolutionary materials that are changing the game. I am talking about eco-concrete and bio-bricks. Get ready to have your mind blown by how waste products are becoming the building blocks of our future. First up, let's talk about eco-concrete, also known as green concrete. This isn't your grandpa's concrete. Traditional concrete relies heavily on natural resources, like limestone and clay, to make cement. Eco-concrete, on the other hand, is a clever, environmentally friendly alternative that cleverly incorporates waste or recycled materials into its mix. Think industrial byproducts like fly ash, which is a residue from coal power plants, or ground granulated blast furnace slag, a leftover from iron and steel manufacturing. It also uses silica fume and even recycled chunks of old demolished structures. This approach is brilliant because it doesn't just save our precious natural resources. It also helps solve the growing problem of industrial waste by turning these byproducts into valuable construction components. Imagine that, yesterday's waste becoming today's robust building material. So what are the actual upsides of using eco-concrete? The benefits are pretty impressive. The big one is a significantly reduced carbon footprint. You see, producing Portland cement, the key ingredient in regular concrete, is a major CO2 emitter, accounting for about 8% of the world's greenhouse gases. That's huge. By replacing a good chunk of this Portland cement with materials like fly ash and slag, eco-concrete can slash these emissions. Some formulas even achieve an average 80% reduction in greenhouse gas emissions per ton compared to normal concrete. That's a massive win for the planet. Beyond that, eco-concrete is a champion of waste valorization. It takes industrial waste that would otherwise clog up landfills and gives it a new, useful life. It also conserves natural resources by reducing the need for mining and quarrying virgin materials. But it's not just about being green. Eco-concrete can actually be stronger and last longer. Studies show it can have enhanced durability, better resistance to chemical attacks like sulfates, and can even reduce permeability and cracking, meaning structures built with it could have a much longer lifespan. Some green concretes also gain strength faster and shrink less. And for the builders, certain additions like fly ash make the fresh concrete more workable, easier to pour, pump, and finish. It often boasts good thermal and fire resistance too. And while initial testing might sometimes cost a bit more, eco-concrete can be cost-effective in the long run, especially if those industrial byproducts are sourced locally. Plus, its increased durability means lower maintenance costs down the line. Where can we use this wonder material? Eco-concrete is super versatile. It's suitable for all sorts of construction projects, from the walls, floors, and roofs of our buildings, to roads and pavements we drive on, massive bridges and flyovers, and even coastal and marine structures, thanks to its enhanced durability. It can also be used to make precast elements like blocks, beams, and panels. Of course, no innovation comes without its hurdles. For eco-concrete, widespread adoption faces a few challenges. Sometimes, getting a consistent supply of high-quality industrial byproducts like fly ash or slag can be tricky depending on the region. The performance can also vary based on the type and source of waste materials, so strict quality control is a must. There can be higher initial testing costs to make sure it meets all the safety and structural standards. And, as with many new technologies, there's a bit of industry unfamiliarity and a natural reluctance to change old habits. Finally, we need clearer guidelines, standards, and supportive policies to really push eco-concrete into the mainstream and ensure its quality. Now, let's shift gears from concrete to bricks, but not just any bricks. We're talking bio-bricks. These are another incredibly exciting frontier in sustainable construction. Traditional clay bricks, the ones we see everywhere, require a huge amount of energy to fire in kilns, making their production a significant source of greenhouse gas emissions. Biobricks offer a fantastic alternative, manufactured using a variety of waste materials, mostly agricultural waste, and sometimes, believe it or not, even human waste. These materials are often bound together using natural processes or minimal binders. So how do you actually make a biobrick? The methods are diverse and super innovative. One common approach uses agricultural residues, things like paddy straw, wheat straw, sugarcane bagasse, cotton plant waste, rice husks, and even coffee husks. These are chopped up, mixed with a binder, which could be lime-based or involve natural additives like fruit pulp or molasses, then molded and simply air-dried. That's right, no energy-guzzling firing needed. Some of these biobricks can be made with up to 90% agro-waste. Then there's a mind-bending technique called microbial-induced calcite precipitation, or MICP. This uses bacteria, like Sporosarcina pasteurei, to create a kind of biocement. These tiny microbes break down urea, which can come from synthetic sources or even human urine, to produce carbonate ions. These ions then combine with calcium ions to form calcium carbonate, which is essentially limestone. This limestone then acts as a natural cement, binding together loose sand or other aggregates into a brick shape, all at room temperature. And if that's not cool enough, another method uses fungal mycelium, the root network of mushrooms. Mycelium is grown on a substrate of agricultural or industrial waste, like sawdust or rice bran. The fibrous strands of the mycelium act as a natural binder, creating a composite material that can be formed into bricks and then dried. We're literally growing our building materials. What are the advantages of these biobricks? Just like eco-concrete, they come with a heap of benefits. A greatly reduced carbon footprint is a major one, as they skip the high-temperature firing process and use waste. They can even be carbon sinks, sequestering carbon from the agricultural waste they're made from. They offer a brilliant solution for managing huge quantities of agricultural waste that might otherwise be burned, causing air pollution, or dumped in landfills. And for MICP bricks using urine, it's an innovative way to treat and valorize human waste. Production is also incredibly energy efficient. Many biobricks are also fantastic insulators, providing good thermal and sound insulation, which can lead to more energy-efficient buildings. They're often lighter than conventional bricks, which can reduce the load on structures, potentially leading to more economical designs and even better resistance in earthquakes. They conserve resources by reducing our reliance on clay. And economically, biobrick production can create local jobs, especially in rural areas with abundant agricultural waste, and can be a cost-effective building material. Biobricks can be tailored for different uses. Some agro-waste bricks might be best for non-load-bearing walls or insulation panels, but others, particularly those developed using the MICP process, can achieve compressive strengths comparable to, or even rivaling, regular bricks, making them suitable for load-bearing applications. Mycelium bricks are great for interior walls and places that don't get too wet. But, similar to eco-concrete, the journey for biobricks to become mainstream also has its challenges. Ensuring consistent strength and long-term durability across different production methods and waste types is still a key area of research. Some types might be weaker than traditional bricks or more prone to water damage without extra treatment. Scaling up production to meet large-scale construction demands while keeping costs down is another hurdle. The logistics of collecting and processing waste or culturing microorganisms need to be optimized. And again, we need industry standards, certifications, and building codes for biobricks to be widely accepted by architects, engineers, and builders. Overcoming old habits and raising awareness about their benefits is also crucial. What's truly exciting is that both eco-concrete and biobricks are fantastic examples of the circular economy in action within the construction world. By transforming waste into valuable resources, they cut down on landfill, conserve natural resources, and dramatically lower the environmental impact of building. This shift towards a circular model is absolutely vital for creating a built environment that can last, and the innovation doesn't stop there. The quest for sustainable construction is driving even more futuristic ideas. Researchers are developing self-healing bioconcrete. Imagine concrete that can repair its own cracks. This involves incorporating microorganisms, often bacillus species, that can precipitate calcium carbonate to automatically heal cracks as they appear. When a crack forms and water seeps in, the bacteria wake up and start their repair job, significantly extending the life of structures and reducing maintenance. Then there's 3D printing with sustainable materials. Construction 3D printing is gaining traction as a way to reduce waste, speed up building, and create complex designs. There's a growing focus on using specially formulated eco-concretes and recycled polymers for 3D printing entire buildings. This tech has the potential to slash material waste by up to 90% in some cases by only placing material exactly where it's needed. So to wrap things up, eco-concrete and bio-bricks are so much more than just new materials. They represent a fundamental shift in how we think about building. By embracing the idea of turning waste into something valuable, and by using innovative, often nature-inspired processes, sustainable engineering is paving the way for a construction industry that is less destructive, less polluting, and far more in tune with our environment. Yes, there are challenges in terms of standardization, scaling up, and getting everyone on board. But with ongoing research and development, increasing environmental awareness, and growing regulatory support, these eco-friendly materials are definitely set to move into the mainstream. We are literally learning to build a more resilient and sustainable future, one innovative structure at a time. That's all for this episode of Fun Facts Online. I hope you're as excited about the future of construction as I am. Join us next time for more fascinating facts from the world around us. Until then, stay curious.